it's a group of demonstrations that I have planned today. All right. So as I always do, guys, in case if you have any doubt from the previous session, you're most welcome to ask me, right? And I'll be happy to answer all the questions from my last sessions. Or in case if you have any other doubt related to Python, you can also ask me that. Okay. And so who's up for the question, guys? Or in case if you're not, so you can simply ask me to proceed further with a beautiful smile. All right, that's great. So I'll just start in a moment, a max 30 seconds, and then we're good to go. All right. Thank you, Raghuvaran, for that lovely smile, and everyone. Yeah, Vamasi, your question is posted to panelists only, and I want to say that. Vamsi, I would like to request you to send an individual mail to me, or sorry, to Upgrad, and I'll send you the solutions for the questions from the past session. Because if I do those questions right now, it is going to consume a lot of time, which I have planned for today's new topic. But I'm very much sure that the documented content that I'm going to mail you when you post me the mail, when you send me the mail, that is going to help you in understanding exactly what is happening there. So it will really help you. Still, my response and support will be there in case if you have any other doubt left, right? And definitely. I will be, a lot of participants connect me on the LinkedIn, like somehow they find me. So you can also post me, your question, the messages. I will ask the upgrade team in case if I'm allowed to share my contact details with the participants. If I am, I will definitely share the details with you and all other participants, and they can connect and so send me the questions directly. And definitely whenever I'm available out of my content, so I will definitely definitely I'm whenever I'm free from my official responsibilities in the daytime. So in the meantime, after that, I'm going to respond to all those questions. It will not be instant, but definitely it will always be there. Thank you, Parin, for that. uh yeah. So Vamsi, you must be receiving some mails from Grant, some official mails. I'm not sure about the exact domain ID. Uh, uh, so I'll ask the upgrade team to send you, right? Because this is recording, upgrade team observers and monitors what is happening in the session. So definitely they'll also contact you, or you can send an mail to info or support. These are some common mail IDs. Generally, I don't deal with these this department, so that's why I don't have knowledge about that. But I'm just trying to help you whatever is possible. Okay, thank you. Great. So Madhip, you have a very good question, and the main course is always in detail. The main course is actually, it's you can say that it is a kind of in-depth content they provide from the upgrade thing. So this crash course basically lays the foundation of exactly what is happening and what's going on, what are the keywords, syntaxes, what are the rules and terminologies, right? What is the grammatical thing, and what are the rules, and how the internal things work. So this crash course, is going to help you in understanding those in detail, in depth content which is provided in the upgrade course, upgrade main course. And this is thanks to upgrade, because they have launched such sessions which help a lot of participants to overcome their doubts or queries regarding the technology they have opted for. Yeah, Subhadi, thank you. Great. Okay, so let's get started with the session, guys, without wasting any time, right? So in today's session, what I'm going to do is I'm going to talk about something new today, and we are in today's session why it is important and why it is beautiful, why it is technically very strong, right? Why nothing can be built without today's module. So I'm going to explain it in detail and with proof, right? So the unique point of today's session is to understand what proof is there, right? Like the proof of performance, proof of less time complexity, proof of less space complexity. So that's something we are going to understand today, isn't it? So let's get started, guys. Let's not waste any time and let's proceed further. All right, so let's get started. Hello Python, old friend. Okay, great. So here's the agenda for today's session, guys, right? I Let me explain the agenda today. So in today's session, we are talking about NumPy, right? NumPy stands for numerical Python. So it says numerical Python, so it basically means, it's all about numericals. Numericals is closely related to mathematics and closely related to numbers, right? So in today's session, what we're going to learn is fun with numbers, right? So how we are going to play with numbers in the form of a 2D array, in the form of 3D array, in the form of matrix, right, or matrices, whatever you say, right? So that's what we are going to play with. Okay, so in today's agenda, what I'm going to do is I'm going to give you the overview of NumPy first of all. Now, overview is very important because this is a strategy that I follow in all of my sessions, right? You know this thing. So in the first, you can say, in the first 10 minutes or 15 minutes, I laid a plot, right? So what's the plot is all about, right? So that's what I'm going to do today, right? And then we're going to learn the key components of NumPy. So the key component of NumPy, whatever NumPy is, right? So okay, I don't know about NumPy, but there is something called arrays in NumPy, right? So that is the superhero of this module. So okay, so we're going to learn about arrays. What is an array, right? And the whole, array is like a sun of this solar system, right? So as all the planets revolve around sun, so everything is going to revolve around arrays, right? So we're going to play with arrays. So it's like fun with arrays, right? So, and then we're going to do array manipulations, right? So in the first section, we'll learn how to, define an array. What is an array? How is the syntax of an array, right? How it is different from fundamental collections such as list, tuples, and dictionary, right? We learned all those things, list, tuples, and dictionary. And then today there's a surprise. List, tuples, and dictionary are very bad in terms of application efficiency, right? So they're very bad. So we will get to know, right? We will understand why list, tuples, and dictionary are bad. We learned all these topics with such enthusiasm and excitement, but today things are taking a new turn. So why it is happening? So I'm going to answer all those questions today. Then then advanced array manipulations is always there, right? So we learn exactly what extra you can do with those arrays, right? And then there are exercises, right? Exercises are actually, except step number one, except the agenda one, in 2, 3, 4, exercises everywhere by default, right? So we're going to learn that thing. Okay. So I hope the agenda must be clear to all of the participants here. So before I start with the session, so I'm gonna ask to all of my participants, right? So how many of you are learning NumPy for the first time? So let's see who is up for the answer. All right, Sajal, Suresh, Neha, Sumit. All right, so there are a lot of people who are going to, start with the NumPy. Okay, that's great, yeah, that's great. That's not great even, because if you have some sort of idea, it is always good, right? But if it is not there, then definitely upgrade to the rescue, isn't it? Okay, so here it goes, like guys, NumPy, right? So what exactly is NumPy, right? Now, before I start with any programming, right? Before I start with any theory, right? So I believe in visualization, guys. I believe in visual things, right? So, guys, let me show you a small demonstration here. and then we'll proceed further, right? So why I'm doing this? Because the training strategy is like, first let's visualize the things, okay? Let's create a picture in mind, and then we will proceed with the theoretical part, right? Because I hate talking about things which I don't have idea about, okay? That's my personal observation, because that's how I used to learn. Hey, Anaconda, I hate you. Okay, same. Everyone, just keep a parallel sync between, between you and me, right? So don't break the, that thin line of connection, right? So it's important. Jupyter, hey, Jupyter notebook, Jupyter notebook. Okay, great. So it is about to start. Tip, 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 tippy tappy. Hello. Oh, my Lord. Come on. Thanks. Okay. So let's go to this drop down. Let's click on Python 3 here. So I'm just creating you know, a new notebook here. All right. So first of all, let's import the module here. Import NumPy as NP. This is a module, right? So this is uh, the library that we are going to talk about today. So NumPy is one of the library available, and obviously this is a built-in library, PDL, predefined library, and the alias of this library is NP. NP is just a short form, right? It's like, instead of writing NumPy every time, I'm going to write NP, right? It's just an alias, helping me in reducing the keystrokes. Just a small logic, okay? So what I'm going to do is I'm going to create an array here, right? So my NumPy array equals to np.array. I have a list here, 5. All right, let's keep it simple, okay? What do you call it? Python list equals to 1, 2, 3, 4, 5. Okay, and here Python underscore list. Okay, print Python list. Hey, sweet, come on, don't spelling mistake. Okay, Python underscore list, print NumPy array, my underscore NumPy underscore array. All right, so here is the beautiful, right? Okay, that's great. So first of all, guys, what we are going to talk about today is this one, right? So this one, my NumPy array. You can see this here, right? So we are having, the values here, 1, 2, 3, 4. So this is Python list, right? So this is Python list that we have printed. This is ordinary, right? We all can understand it very easily, right? What is happening here? But what I have done here is that here in this step, what I'm doing, it's a very easy thing, right? Listen to me carefully. I'm converting a Python list into NumPy array, right? So NumPy array is a new data type that we are going to talk today. So I'm converting a Python list into NumPy array. So there is a conversion, right? You cannot create an array, directly. You create an array from a predefined type, right? So I'm converting a Python list into a NumPy array, and then the values are getting stored inside my NumPy array. Although when I print the values, both the values are similar, both the values are same, right? So I'm getting the same thing, except the presentation where the values in list are separated by comma, and NumPy it's not. But comma is something which we're not focusing here, right? What we are focusing is that I'm getting the same value 1, 2, 3, 4, 5, and NumPy array 1 to 5 once again. But how does this NumPy array makes the difference, right? What is the difference here, right? Why it is special? Why nothing can be built without NumPy array, right? When I say nothing, it includes your image processing in Python. It includes your artificial intelligence. So when I say artificial intelligence, it includes your machine learning. It includes your deep learning. It includes your data analytics. It includes your image recognition, right? So whatever it includes, TensorFlow even, right? TensorFlow is one of the beautiful library from Google for AI. So nothing can be built without NumPy array. So why is it the case that the companies or the developers or the creators or the community is not using Python list? Why they are crazy behind this NumPy array? So this is the today's session understanding, right? So what we're going to do is we're going to identify, right? Right, we're going to identify what is NumPy array. We're going to prove, right? Sorry, prove. So we're going to prove. Is that spelling okay? Is that double O? It's single. Okay, fine. You know, I should stop learning multiple things. Okay, so just for fun, right? So we're going to prove exactly why NumPy is important, and then we're going to play around with NumPy, right? So then that's how it is going to work today. Okay, so I hope everyone got the idea exactly what we're talking about today. Everyone, can you confirm me, guys? Have you got the idea exactly what we're talking about today? Okay, great, great. The best part, now you have a picture in your mind, right? What we are talking about. So let me start with some theoretical part, right? So here is NumPy. Okay, so here is NumPy, guys. Okay, this chat window. Okay. So NumPy is the most basic and powerful package for working with data in Python. So okay, this thing I left, right? So let's say suppose you are doing data analytics. Let's say suppose you are doing data analytics, and when you are doing data analytics or even machine learning, whatever, right? Both the things, right? Or let's say machine learning, right? Both the things require you to play with data, right? Both the things require you to play with data, and the very first thing that you do with the data is store, right? And the very first thing you do with that data is to store that data, right? And for storing that data you need a data structure, right? For storing that data you need a data structure, and here NumPy array comes into the picture, right? So this is the story, right? This is the sequence, right? Just let's understand the sequence exactly, how NumPy is getting involved in everything, right? So when you are doing, let's say, data analytics or machine learning, you require to play with the data. You understand what is playing, and then before manipulating any data, let's say before cleaning the data, before filtering the data, you need to store the data. And for storing the data, you require a data structure. And here, NumPy array comes into the picture, and then we're going to realize or prove exactly. Why NumPy arrays are better, right? So it's all sometimes some people call it NumPy array, right? I wonder why, but it's okay, right? I have no issues. All right, so this is what the slide says. NumPy is the most basic and powerful package for working with data in Python. So what I'm emphasizing here is that for working with data, right? So these are the four words here, right? For working with data. So NumPy helps you in working with data, right? So it's like that. So NumPy is mandatory to learn, right? Sounds like Mandarin. Okay. So now NumPy is mandatory to learn when you are learning data analytics or when you are learning, let's say, machine learning and various other domains, right? So this is just a clue exactly why you need to learn NumPy. Now, what is the key to end dimension to NumPy, right? What is the thing that is makes the NumPy array powerful? And here is the answer: print type my NumPy array. Hey, sweetie, come on. I hate you. Okay, this thing takes some time sometimes. I don't know why my system is not performing today. Hey, hello. Okay, let's create a new notebook. Come on. Is that how you are supposed to behave, laptop? Hey, come on. This is really bad. So what's the type? Samir, can you just post this to chat? Yes, Maulik. You know, okay. What's time? Jupyter Notebook. Okay. Okay. Okay, let me perform my turn also. So then that's beautiful, right? Isn't it? I can see some good responses here. So yeah, that is the key to NumPy, right? Okay, all the participants here, right? You can see the chat window. So when you print the type of your array, it says numpy.nd array, and that's that's what we're talking about today, right? So the key to the performance of your NumPy, or the key to the reason why everybody is crazy behind NumPy is the nd array, or the n dimensional array. So why it is called n dimensional array, guys? Hey, where are you? Right. So why it is called n-dimensional array? The reason, because you can create any dimensional, right? Any number of dimensions in this NumPy, whether it is a single dimensional, 2D, 3D, or n-dimensional array, right? So it depends on how many brackets you are putting inside the codes, right? So then that's how it goes like. So NumPy, it's a fundamental library, right, needed for scientific computing with Python, right, and it's called NumPy. So it's not only that it is required for scientific computing, right? So you can use it for n number of ways, n number of purposes. So it's a powerful n-dimensional array object and advanced array slicing methods, right? So this is something which is important, and I think I'm very much sure that at least 98% of the participants can understand this thing, that advanced array slicing. So when I say array slicing, it's the same thing that we have done in string slicing, and it's the same thing that you have done in list also, right? So it's what slicing is, right? Slicing is all about extraction of data, extraction of required data from the given data set, isn't it? So I hope you understood, right? Okay, and then we have something called convenient array reshaping methods. So what does it mean? It means, let's say, suppose I have a single dimensional array, right? Suppose this is I have something called, let's say, 1, 2, 3, right, and 4, 5, 6. Okay. So what dimension it is? It's like 1D array, right? It's like it's a linear data structure, right? Suppose I want to reshape it. So what does reshaping means, right? I'm talking about the third point here. So from 1D, so let's convert it to 2D, right? 1, 2, 3, 4, 5, 6. So this time it is 2D array, right? So this is called reshaping, guys, right? What does reshaping means? It's just changing the dimensions, right? From 1 to 2 to 3 to n number, whatever you want. Okay, so this is what reshaping means. Okay, now let's get back and okay, let's get back. So as I told you guys, NumPy key is n-dimensional array, right? It is maintained by a large community, which is you can just go through this website numpy.org, right? That's how it goes like. And so okay, this is a theory, right? So I'm just going to tell you briefly here, right? So if you're going to work on data analysis, or let's say machine learning projects, right? So then having a solid understanding of NumPy is, it's mandatory, as it was said in the first slide, right? And the key to understanding NumPy is ND-array. So NumPy is an open source library. It's available in Python. And why we use NumPy, right? So the very important part, why we use NumPy, and there are only two things that we need to understand, right? So here it goes, like I'm going to touch a little of data structure here. Okay, so I'm really bad at data structures, but something that I've learned in data structures is this. Okay, space complexity. Right. Okay, so so this is something which is there, right? So time and space complexity. So whenever you work with data structures, right? So suppose you have anything, right, with you. Let's say I have a list here, right? Now, what will you expect from this list apart from storage, right? What is that other thing, right, that you will expect from this list apart from storage, right? So the expectation is like it should consume least memory possible, right? Yeah, that's true, Nishan. That's true, Darshan. That's true. Thank you very much for that. Those are one of the expectations. It should consume least memory possible, isn't it? So that is something that we want from our data structures. And Okay, fastest performance possible, right? So while you are doing, let's say, some CRUD operations. So when I say CRUD operations, it's like create, read, update, or delete, right? Or traverse. All right. So yeah, high accuracy is also there. High accuracy is basically, there's a dependency for high accuracy, and that is algorithm, right? High accuracy is dependent on algorithm, right? And that will also require exactly Pratik. Okay. So let's do it once again. So I'm just creating a plot here for the 5 minutes. So whenever you construct a data structure, basically you expect the data structure to consume least memory possible. So it should be least, right? So if your data structure is consuming, if it is hungry for the RAM, right? So it's not going to work, right? And that's why the the technologies fail, right? And that's why the Python data structures have failed actually, right? So that sounds horrible, but that's actually true, right? Okay. Now, fastest performance possible. Yes, that is also required, right? Performance is one of the factor, and performance is the key to selling today, right? I think performance is the key to selling today, right? I think a lot of smartphones today in today's market are selling their smartphones on the basis of performance only, isn't it? And a lot of mainframe servers or supercomputers or some desktop computers, laptops, what they're doing exactly, every company is selling their products. So performance is one of the a key factor to sell anything, and it is equally important in programming or technologies as well, right? So that is what we want from the data structures. The reality to all these things is that Python data structures are bad, right? So Python data structures, hey, are bad, right? BAD, bad. Okay, so they're bad, right? So they're very bad at memory optimization, right? I'm going to prove you, right? So how why they're bad. I'm going to show you perfectly exactly how it is happening. And then Python data structures are very bad at performance too, right? They take a lot of time, right? They take a lot of CPU cycles, you can say, for producing the output. So Python data structures are bad. Hello to NumPy and the array, right? So hello to NumPy and the array, and why we are learning ND array, and there are only two things that we want, right? So ND array satisfies both the requirements, right? So ND-array satisfy both the things, right? So why every company is working around ND-array? The reason is because ND-array consumes least memory, right? So I'm going to show you exactly how much least it consumes, and ND-arrays are fastest possible, right? So ND-arrays are they're very fast, right? The reason why they're very fast. So for this, let's do an activity, right? Let's do an activity here. So can I ask my participants to open Wikipedia and uh, open the page for NumPy? And can you just post this section, right? In which language this NumPy is written in, right? So that is going to expose exactly why NumPy arrays are very fast, and why they consume the memory to the to the least possible, right? Yeah, Lakshmi, Dina, and Rekha, that's absolutely true. We we okay, we okay. I want to say that spoiler came a little early, isn't it? I was expecting at least 15 seconds there. No worries. That's true. That's okay, right? That's okay. I appreciate prompt answers, isn't it? Okay, that's good. Python and say, right? Okay, Python is just an abstraction for NumPy, right? Just just a mediator between Python and C, right? So not, Python is not performing the much of the task, but mostly C and C++ and all, right? So all these things are basically, performing the main, magic behind what is happening right inside. Okay, so now I believe that we know exactly why we are talking about NumPy and why every company is crazy behind NumPy. So let me tell you one more thing here. So let's say I have a data, let's say, of let's say New York, uh, New York, what do we call it? New York taxi, right? Uber, right? So let's say I have a data set right from the New York taxi, and the provider is Uber, and for every month, they're providing. For every month, let's say for Jan, they're providing 1.5 GB of data as their what do you call that? What do you call that? Taxi hire information, right? Okay, and till December, it becomes 1.5 GB, 1.5 GB, and 1.5 GB, and so on, right? So that's how it is going to work. So in order to accommodate 1.5 GB into 12 months of data, right? So in order to accommodate this much size of data, let's say, or even 1.5 GB even, right? So in order to accommodate 1.5 GB of data in a single shot, you require a data structure which requires less memory, right? Which requires less memory. It is not only important in terms of performance, but it is also important in terms of commercials as well. Let's say if a company requires additional costing for performing some, you know, some operation, some statistical analysis. So obviously, the company would like to choose a technology which reduces the processing cost also, right? And that's where NumPy comes into the picture. So just an example from old memories. Okay, let's close this. So what we have here, okay, we have covered agenda, we have NumPy, okay, continued, okay, we have done that. Okay, we have done ND array also. Oh my god, so here it goes like, so this is the practical time here. So Nishant, here Nishant has a question, so I'll just repeat it once again. So what I was telling you is that when you deal with the industrial data, the industrial data comes at least in the form of GB, right? So let's say according to statistics, NASA produces 1.3 to 1.5 GB of data per second, let's say, right? So I studied it somewhere. So in order to process that size of data, you require a higher level of infrastructure. So in case if you're choosing a technology which is which is consuming memory without optimizations, and it's consuming memory like anything, so you over that you will choose a technology which can just reduce the memory consumption, so that it will also reduce the infrastructure cost as well, right? So when you choose when you go for NumPy kind of technologies, it helps the vendor or the business community to reduce the infrastructure cost as well, because it's consuming less memory. Otherwise, you have to find some other solutions for that. So less consumption of memory is one of the feature why companies go for NumPy. That's what I want to say. Okay, fine. So let's get started with the NumPy demonstrations, guys. Okay, now one thing I want to say to all of you here, in today's demonstration, in today's lab or today's practical, we're going to work with n-dimensional array, right? I'm going to show you exactly how to work with ND arrays, but this doesn't make much sense in terms of solving a question, right? So in today's session, I'm not going to solve any question. I'm going to play around arrays, and then let's say in my next session, I'm going to show you exactly how ND arrays are used in a real sense, right? So that's how I have planned this session today. Okay. So enough with the theory part, right? So we have already spent half an hour on theory. So this is for the first time I've spent this much time. Okay, Okay, let's get started with the practical part. So where is the Jupyter friend? Thank you, Nishant. And please post to the attendees as well, Nishant, okay? So that they can see the questions as well. Okay. So let's go to new and let's click on Python 3. let's give it a beautiful name here, and this is NumPy arrays. Right? Import NumPy as NP. Here, NP is an alias. NP is an alias, guys. So what is an alias basically? Alias basically helps you in reducing the keystrokes, as I told you earlier. So if I'm going to call some function, so instead of writing the complete NumPy, I'm going to write NP only. You can make it N also, right? So that depends on the choice. Okay, so that's how it goes like. So yeah, so I'm going to I've executed the cell, and now my NumPy has been executed. Okay. So I'm using but that's how we check the version, right? So in case, and this is common across any module, right? So whatever module you use, you can check the version, right? Check version. Checking version is sometimes helpful when you are getting some bugs. Let's say if you download some sort of code from Google, and in case if it is not working in your system, right, you're getting some sort of error. So in most of the cases, right, like as per my past experience, I found that there was a version issue, right? So Python has this bad thing in its backside, right? You can say like that. So Python is very bad at versioning. In generally, whenever the version changes, there are always certain issues that we face. Okay, but changes are for good, right? Okay. So here it goes, like. Thank you, Vinita, and that's good, Manish. That's good. Okay. Okay, let's get started. Let's create an array, guys, right? So I'm just repeating my first demonstration again. So let's create an array. Yeah, nobody is using the similar as I'm using. Okay, okay. I'm the unique one, actually. That's why. Okay. Okay, create an array. So, uh, okay, and then my Python list underscore list equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and then print. Okay, NumPy array underscore array equals to np.array and then Python underscore list. Okay, so here we have a function called np.array, right? So np-array is a function, which basically converts any given input into the numpy array, right? So you can just give it a try, right? So np.array, what it does, it just does casting. You can say like that. We're just converting the Python list into numpy array. And let's print the numpy array here. So numpy underscore array. So here's what's the numpy, right? Okay. Okay, so we have printed the numpy array, and let's print the type as well, right? Okay. So this time here it goes like class numpy.ndarray. So that's how it goes like. Okay. Now, what we learned in this demonstration, we just saw that exactly how to create the NumPy array, right? That's the only thing that we have done. Now, in the next demonstration, what I'm going to do is here. Okay. Properties, attributes, and functions of NumPy. Right. Okay. Let's explore, right? Okay. Okay. What are the Okay, so let's explore what are the attributes and functions of NumPy, which will help us in getting to know NumPy in more detail, right? So let's do this. All right, I hope I'm not going fast. Okay. Hey. Various data types. All right, so this is the title, arrays of various data types. So x equals to np.array. Okay. 1, 2, 3, 4, and 5. Okay, so guys, this time don't get confused, right? In the previous demonstration, I was creating the numpy array from an existing list, and this time I have statically and directly given the list into the method array, so that's completely fine, right? So okay, so the nd array I'm creating here is x, right? Okay, the variable name can be anything, right? So it depends. Okay, so if I print x, you can see here. Okay, numpy array. I'll just include the messages as well, so that it is convenient for the participants to know exactly what is getting printed, right? Print data type, right? So let's print the data type of this numpy array. So what data type it is, right? So x dot d type. All right, so you can see it here, guys, right? So there's an attribute called d type. D type is basically telling you exactly what is the data type of the values there, right? So whatever values I've given here, what is the data type of these values, right? And it is int 32, means it's like 4 bytes, right? So each integer is a 4 bytes here. That's how it goes, like. Okay. Now, guys, can I ask you for the attention here, right? Just listen to me carefully, okay? Okay, listen to me carefully. Now, just pointing out something, and then I'll get back to this point once again, right? So right now you can see here in the data type section, in the D type, it is printing int 32. So of individual values. So from these given values, the one is int 32, right? It's like this. So I want you to observe the representation of the values and their data type, right? Because data type is the key to know the size, right? Data type, listen to me carefully. Data type is the key to know size. Here I'm talking about space complexity, size. Okay. So here right now, 1 is int 32. Now for a simple Python list, 1 is class int, right? So there is a difference, guys. Observe this thing, right? Just observe this thing. Why there's a difference in the memory consumption of Python list, and why there's a difference in the memory consumption of NumPy elements or NumPy values, right? So it's a small hint, right? I'm going to get back with a bigger example, but I found something to observe. I wanted to tell all of you. I hope you understood exactly what I'm talking about here, right? And that's why the difference in size, right? Okay. My God. So that's how it goes like. Okay. Let's try one more time. X np dot. Okay. Okay. Let me ask my participants here. Create another array with these values. Okay, everyone. Wait. Just some environment. Okay. So guys, in the meantime, I want the participants to create numpy arrays with these values, different numpys with different values. So one numpy array, two numpy array, and three numpy array, and print the d type, right? I just want you to explore these things, right? Okay. So I have a question here in the chat window. I'm just taking up the questions till time you do it. Right? Okay. So Sajal, you have a question. You say that what is the difference between these two types? So can you point out exactly what? Acha, got it. What's the difference? Okay. So Sajal, the difference is that in the NumPy array, the int32 is a C representation where on an individual number is getting created in the C integer form, right? In the form of integer as we create it in C, right? So in C, an integer is not a class, right? Right? So it's not a class, right? But in Python, the integers are classes. So when it is a class, it is bound to have some sort of attributes, some constructors, functions along with it. So that's why it takes a lot more memory compared to the individual number represented in sieve type, right? So I hope you understood exactly what I'm talking about here. Okay, thank you, sir. let's manually specify, right? Let's manually specify the type here, right? So I'm going to show you some, an additional thing here. Okay, everyone, that's beautiful, right? That's beautiful. I can see people working, right? That's what I want. Okay, good, good. So in case if other participants are not having software in their system, they can simply use the online IDs, right? Simply, just play around with these numbers, right? So it is going to really make your day. Okay, so here what we have here 1, 2, 3, 5, and then t type equals to np dot int 64. Okay, print x dot t type. N64 is basically the long representation. Okay, what's the problem? Did I miss something? D type. Okay, great. Great, Manish. Thank you for your lovely response. Thank you, 97398. Thank you, Manish. Great, excellent. Neha, true, false in Python, true and false are having the capital letters. The first letters are always capital in Python, right? So it's like T and F. And when it says less than U5, that is a string, right? That is string representation. Okay. So guys, this is one of the method of specifying, the data type. Exactly. So in the array method, right, after placing the comma, you can simply use the d type parameter. D type is one of the parameter in the array method, right? And you can specify whatever data type you want. So I wanted these numbers to be of int64 type, means it is going to occupy 8 bytes. And every individual number is going to occupy 8 bytes, right? So that's how it is going to work. Satya, as per your question, what you have posted is that what is NP, right? So that is a question, Satya. So NP is a reference to NumPy module, right? So it's an alias that we're using instead of NumPy. So what if I don't use NumPy NP? So in that case, I have to write this, right? NumPy.array. So I have to call methods of NumPy module by writing the complete module name. So in order to save the keystrokes in terms of time, right? So I just created an alias of NumPy module as NP. So when I do this, I just need less keystrokes. It saves my time and it's less complicated. That's why I've done that. Satya, I hope you understood this answer. Okay, great, Satya. Thank you very much. Thank you, Samya, for that lovely example. Okay. So guys, can I ask my participants, everyone, are there any confusions or doubts regarding NumPy array? So when I say doubts, it basically means what and why, right? So what is a NumPy array and why NumPy array? That is the most important part here, right? That's you need to understand. Because if you don't understand all these things, the context remains, what do you call it? Fate, right? Invisible or whatever. Right? Okay, great. So sometimes saying no is good. Okay, let's proof of time. Okay, NumPy. Now in this demonstration, guys, what I'm going to do is I'm going to show you the time performance of NumPy, and this demo is going to be little extended. So I just want you to observe, right, exactly what I'm doing here, everyone, right? So make sure you're concentrated, right? Okay. So in this demonstration, what I'm going to do is, shall we go for time or shall we go for the, okay, time is going to be a little complicated. Fine. Okay. Okay, let's do this, right? So I'm going to create two lists here, right? Right? list 1, list 2, everyone, right? Let's understand the question here. Let's understand the question, right? Question. Objective to prove that NumPy takes less time in computing compared to Python list. So this is what we're going to do, right? So in order to do this, right? So what I'm going to do is I'm going to create two lists here in Python. So it's like plist, plist1 and plist2. I'm going to add these two lists, and in every list I'm going to have, let's say, okay, just give me a moment. 10 lakh. I hope that I'm right. Okay. So I'm going to have 10 lakh elements in each list. So it's like 10 lakh plus 10 lakh. So it's like 20 lakh, right? So that's how it is. Hey guys, can you hear me now? Hello everyone. Okay, great. Now I'm still breathing. Great. I don't know what happened. Okay. Okay, guys. So yeah, what I was talking about. So yeah, so the objective is to prove that NumPy takes less time in computing compared to what we have in Python list. So for that, I'm going to prove, right? I'm going to create two lists of 10 lakh elements each. So I'm going to add 10 lakh plus 10 lakh, that is 20 lakh. See how fast the computing is. Okay. So I'm going to do this with NumPy also, right? So I'm going to do the same thing with the NumPy list also. So I'm going to add two NumPy arrays of having 10 lakh elements each, right? So what we're going to do is I'm going to count the milliseconds. Here also I'm going to count the milliseconds. You can very well understand that we need to count milliseconds. You know why? Because no, even Python is good at less than 1 second, right? But it is going to make difference in terms of milliseconds, right? So because systems are very fast, so we'll see the difference in terms of milliseconds, exactly how much difference is there in the in the computing time, and that is something which will create an enormous confidence in adopting NumPy, right? So let's get started. Okay, I have to do it quickly, right? Everyone, right? Look at the codes here, what I'm doing, okay? So for this, what I'm going to do is I'm going to import a module called time, right? So time is a module which helps you in tracking time, right? So okay, so time is a module which helps you in tracking the time, okay? Because I told you that we're going to identify the difference in milliseconds. So what is millisecond? It's a time. Remember Dr. Strange? Yes, it's somewhat related to him. Okay. Now here we have a variable called size, and then okay, I hope I'm good at numbers. So it is 10 lakh. If it is not, you can simply tell me, right? Okay, stop counting. So here it is size equals to 10 lakhs. So this is the size here. So I'm going to create the Python list here, right? Python list 1 equals to range size, right? So this is just a Python list that I'm creating here, and then let's create a Python list to range size. Okay, so guys, it's very easy, right? I hope everybody is getting exactly what is happening here. So I have created two lists here. Okay, so Python list one, py is just for identification, exactly what we are talking about, whether it is an array or a list. So here we have two lists, list one, list two, right? And then I'm going to numpy array1 equals to np dot a range size, right? A range is equivalent of range in Python, right? So you know that, right? Range is a generator. It generates numbers, right? Isn't it? It generates numbers. So a range is also a function which does the similar task. Just it is just having some extra a, right? Okay. So numpy array2 equals to np dot a range size. Okay. So here it goes, like, right? Okay, great. So what we have here, guys, we have two sections here, two pairs here. One is the Python list, second is the NumPy arrays, and we're going to add these two things, right? So before adding Python list and NumPy arrays, I'm going to track the time, right? Okay, so let's learn how to track the time. Start equals to time dot time. Okay, returns seconds. Okay, so this is going to return the current seconds that have elapsed, right? So it is going to return the seconds, right? So in case if it is still not understood, it is going to return seconds from January 1, 1970, I believe, right? If I'm not wrong. Okay, so how many seconds have elapsed since January 1, 1970? It is going to return this kind of figure or number, right? Sometimes we call it ticks also, right? Ticks, and I'm not confusing you. Ticks and seconds both are same, right? So I hope this is understood, right? So what we have done is that I've just started recording the timing here, right? I've just started recording the time, right? So this is what we have done. And then what I'm going to do is I'm going to use a list comprehension here, right? I'm going to use a list comprehension. This is going to be a little tricky for all of you, but just understand this thing, right? So take it easy, guys. So what I'm going to do is zip py list 1, py list 2, right? So zip is a function, right? What zip function does, it extracts the values from each list. Okay, so zip function is going to do, it is going to extract the values, okay, from each list. So it's like take out the 0, take out the 0, and then once again take out the 1, take out the 1, once again take out the 2, take out the 2. You got it, guys? This is how it is going to work. It is going to extract, it's like a puller. It pulls the values from the given list one by one, right? And what it is going to do with those numbers that is going to pull from the given list is going to store the numbers inside X and Y. And I think you have you're going to apply some common sense there, right? So what X and Y is going to store? Can I ask my participants what X and Y will hold? Yeah, excellent. Good. Good. The values, right? Yeah, one by one. Exactly. Yeah, good. Excellent. Vasu, then there will be some exceptions or none, right? None will be there. Great, one by one, right? Okay. Now, what is going to happen with X and Y, right? Okay, because this is a repetitive process, because extraction is a repetitive process, that's why we're going to apply loop here, that is for, right? Why for? Because it's a repetitive process, right? Extract 0, 0, 1, 1, 2, 2, 3, 3, like that. It's a repetitive process. So what it is going to do with those X and Y, right? It is going to add those X and Y, right? So it's like 0, 0 for the first time. So X and Y will be 0 and 0. And then X plus Y, 0 plus 0, let me count. 0 plus 0. 0, isn't it? So 0 plus 0, it's 0, right? And then second time 1 plus 1, 1, 1 plus 1, 2. Because both the lists are having the similar values, right? Once we cannot use while loop here because it's a comprehension, right? That's why. Okay. Now this is the comprehension bracket. When I say comprehension, it has to be enclosed in a square bracket, right? And the new list which is going to be generated, right, will be stored inside result, right? So result will look like this: 0, 2, okay, 4, 6, and so on, right? Result will look like this. So the first x and y will have 0, 0, 0 plus 0, 0, 1, 1, 1, 1 plus 1, 2, 2, 2, 2 plus 2, 4, and 3, 3, 3 plus 3, 6. Okay. Oh, that was complicated. So guys, can I confirm? Have you understood this expression here, everyone? Okay. Please post to attendees as well, guys. Please post to attendees as well. Okay. I think all of you can see the screen as well. Great. Now, as we have finished the addition of both the list, what we are going to do is we are going to stop the tracking of time. Okay. Let's stop tracking time for Python list addition. Okay, let's stop tracking time for Python list addition. Right. So this is what I've done. Now what I need to do, right? This time what I need to do? I need to do subtraction, guys, isn't it? Yeah, good. So stop minus start. I need to do subtraction. Okay. But because when I do the subtraction from the numbers, right, whatever numbers are going to come, when I do the subtraction, the number is going to be in the form of this thing, right? Like this is how the subtraction value will come. Yeah, Vasu, we can do that. So when I'm going to subtract start and stop, the value is going to appear in this form. You know the reason why? Because we are working on right now. Working on, let's say it's Core i5, I believe, right? So I'm working on Core i5. So it is fast, right? It's not going to take 1 second, isn't it? It's going to take some whatever seconds, right? Some very less CPU cycles, right? So the output is going to come like this, right? It's in the form of nanoseconds. No, it's not. It's not milli. It's nano or micro, right? Whatever. Okay, great. Thank you, Himachal. Okay, now what I'm going to do is I'm going to multiply this number with the 1000, right? So that I can convert those microseconds into milliseconds, right? So I'm just converting, okay, micro into milli. So let's do this into 1000, and then Python computing time, okay, equals to. Don't you think it's a very long name? I'm really bad at naming. Okay. Chalo, let's go with this, right? Okay. So what I've done is that I've just simply what I've simply calculated the time here in milliseconds, and this time let's do the same computing for the NumPy array, right? So how we do the NumPy arrays computing, and before that, once again, we need to start the time tracking for NumPy array, right? Okay. And this time, what I'm going to do is this time I'm going to add, what's that, numpy array1 plus numpy array2. Look at the beauty of no complexity, isn't it? It's not at all complex. See how beautiful it is. Python is popular for its simple syntax, but when you come to NumPy, it's simpler. So that's how it goes like. So we have added both the arrays, right? So np array1 plus np array2. Let's stop the time, and let's numpy underscore array underscore computing. I'm really bad at naming, seriously. Stop minus start in 2000. Okay. So I just stopped the timing here, right? Okay. Yeah, Neeraj, that's true as a whole, but internally it's happening individually. Hey, Himaja, it's not mandatory to specify semicolon. It's just coming hereditary from C++ and Java programming, right? So, my fingers are having some sort of memory. Leave it. Okay, fine. So let's do the printing here, right? Final time. Here are the results of Python versus NumPy. All right. Okay. I wish we could have a background music here, like steel. Okay, whatever. Okay. Python list truth. Okay. Thank you, sorry for that. Python underscore list underscore computing. Okay, underscore time milliseconds. All right. Print NumPy array took. Hey, okay. NumPy. I'm bad at okay, this thing. NumPy underscore L underscore computing underscore time. Hey, somebody has got the spoiler alert. Oh my god, Sajal. Thank you for that, but it feels happy actually. uh, Thank you for that lovely smile, Sajal. Hey, I'm really bad at this. What I have done. NumPy underscore L underscore computing underscore time. Oops, I must use comma here. My time. Okay. Great, Aarti. Great, Malik. Thank you, Nagesh, for the response. So we can see here, guys, finally we have done this heavy program, right? Oh my God, Manish, you're very good at this thing, right? What sort of system you're using? Okay. So in my, according to my system, guys, here is the difference in the time complexity of Python as well as versus NumPy here. So here are the numbers, guys. Finally, the election results are out. So it is like 235 milliseconds in case of Python list, and in case of 17, in case of NumPy, it is 17 milliseconds. So I believe that's a huge difference, guys. It is enough for us to get convinced from the NumPy performance in terms of, speed efficiency, you can say, right? So obviously, it is going to be huge. Sri Rama, you're going to, you're also using a good system, Sri Rama. That's great. Okay. Raghuvaran. That's great. Great, yeah, great. Excellent. Okay. Okay, great, great. So I think that is enough, right? So let's complete the second demonstration for the space complexity, and then we'll work with more ND array attributes and functions, right? So that is also important. Neeraj, that's not true actually, but if just to avoid errors, if you keep the size same, so that will be helpful in the experimental phase, right? Okay. Yeah. Okay. Great. 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 Fine. So, guys, can I ask you, are you convinced with the performance of NumPy? Great. Excellent. Excellent. So, let me show you the space complexity also, right? Okay. Okay, great. So let me show you the space complexity also. So in case of space complexity, right? So how much space this consume, right? So what I'm going to do is the objective, right? So or the plan, I'll say, right? I'm going to create a list of, let's say, 1,000 elements, and array of same elements, right? Array of similar, array of 1000, right? Okay, let's calculate sweet sweet the size in bytes. Okay, so that's what we're going to do today, right? So I'm going to create a list of 1000 elements and then the array of 1000, and I'm going to calculate the size in bytes, right? So let's do this. So this time I don't need time is not required here, and this time I'm going to need sys, right? Sys is one of the beautiful module available in Python from the standard Python. So it has a beautiful function called get size of, right? So there is a method within this module, get size of, which returns size in bytes. Okay, so that's why I'm using this module, right? So so the reason, once again, the reason behind using the sys module is that it has got a function called get size of, and it returns the size in bytes. Okay, so that's why I'm using it. Okay. So let's create a list, a Python underscore list here, right? So I'm going to use the range function here, and I'm going to use numpy array here equals to np dot a range, I believe, isn't it? Np dot a range 1000. Okay, so this should be understood, everyone, right? So I've created two people here. That's a nice question, Satya. I think we don't, but star is there from an individual module, right? Okay. Thank you for that, lovely Ismail. Fine. So here it goes like this. So here Python underscore list range 1000 numpy array range 1000. Okay. Now let's print the size. Let's print the size of Python list, right? Okay. So guys, everyone, look at the formula, right? How I'm doing this, right? You need to observe exactly what syntax I'm following. Sys dot get size of 5. So guys, can I ask you what it is going to return? No, it's not going to return entire size of integer in context to Python, right? Not in context to NumPy, right? Because 5 is not from NumPy. Five is an integer which belongs to Python by default, right? So get size of is going to return the size of 5 in context to Python, right? So what is the size of a number 5 in context to Python, right? So in Python, if there is any integer, it is going to occupy how many bytes, right? So you can see here in Python, a single integer occupies how many bytes? 28 bytes. Don't you think it's worse? When I was learning C++ and C# and all, we used to learn that integer is of 4 bytes. That's beautiful. Short is of 2 bytes. That's also very beautiful. We have byte. Byte is 1 byte, and then we have long 8 bytes, isn't it? Then we used to have some bigger numbers also, but 28 bytes is more than enough, isn't it? We used to have a decimal which was of 16 bytes probably. So in C#, I learned that decimal is having 16 bytes of size, which used to feel a huge memory occupancy when it was 16 bytes. Is that Pratik? Okay, but here in Python, a simple number is going to occupy 28 bytes. So that's really poor. What about 1000 elements, right? So if you multiply the size, if you multiply the size of individual number by the number of elements in a list, try to understand the formula, right? So if you multiply the size of an individual number by the total number of elements, right, you're going to get the size of memory occupied by a Python list. 28,000 bytes just for 1000 numbers, and that's really bad. That's really bad. I hope not. If not, I hope nobody's happy after seeing this 28,000 bytes, isn't it? Consuming 28,000 bytes for 1000 numbers is very huge. Okay. Now let's find out print numpy underscore array dot item size. Now this item size is a property which is going to return the size of individual number, any number, let's say 0, from numpy array. Okay. But see, now it is returning the size of individual item. I said size of individual item, right, from the numpy array. So in Python, it was 28 bytes, and in NumPy, the size of individual item is 4 bytes. There is a difference, guys. Now, what if I multiply the individual item size by the total size of your NumPy? It's equivalent to len. It's equivalent to len. Okay. Total size. What is total size? 1000. What's the individual item size? 4. Isn't it? Memory occupied by NumPy array. That's because you have int64 Aarti. Why don't you use the dtype parameter? Right? Okay. What happened here? Am I doing? What's happening here? Dot NumPy. Yeah, that's true. That's true. Sorry, guys. Okay, fine. Thank you, everyone. Right? Thank you, everyone, for that lovely response, lovely support. That's appreciated, much appreciated. Okay. What I'm saying here is that a huge difference in memory occupancy for 1000 elements. So yes, that's a huge difference, right? So for the same 1000 elements in Python, it is occupying 20,000 bytes, and for the same number of elements with the same values in NumPy, it occupies just 4,000 bytes. Now just imagine how many numbers you can accommodate in NumPy for 28,000 bytes, right? So that is going to be huge, right? So I'm going to learn the table of 4 now. 4 1 are 4 and so on. Okay, leave it, right? That's all homework. Okay, 7,000. That's true. That's true. Shrikant has a very good question. Can anyone answer the question of Shrikant? I hope you must know this because we have discussed it. The question is, what is the background for list occupying such a huge memory? So he's asking why the Python list are occupying huge memory. Why? Yeah, that's true. That's absolutely true. Excellent. Appreciate it, guys. Appreciate it. Because in Python, a list is a class. So every number, 1, 2, 3, 4 is a class. It's like class 1, class 2. 1 is an object of int, 2 is an object of int, 3, like having multiple objects, right? So objects do occupy extra space. Shrikant, I hope you understood. Shrikant, dtype is a parameter for specifying the data type, nothing else. Okay. Okay, Shrikant, data type class is a custom data type. It's a user-defined data type. Sergel. Shrikant, Shrikant, Python is constructed in such a way that all the objects are created, all the available keywords, functions, and numbers are constructed in the form of classes only. I don't know why Guido van Rossum did that. He is the architect of Python. Maybe he was, inspired from or obsessed from object orientation. Satya, can you repeat what point you want me to explain? Sajal, I'm going through your code. Sajal, you're doing the wrong code. Sajal, can you please recopy the code? Satya, in case, okay, I'll answer it once again. So let's say, okay, let's say, okay, all the elements or whatever we have in simple standard Python, whether it is a number or a character, is constructed in such a way that it is going to be an instance or object of an inbuilt class. So in C and other programming languages such as C# or Java, all the elements are not constructed in the form of class in order to save memory, right? But in Python, everything is constructed out of a class. So it is a drop. It becomes a drawback actually in terms of memory consumption and time performance, or memory, or you can say speed efficiency, right? So that was the bad decision actually, I'll say like that. But I don't know why it was done like that, but I think we both need to Google on this. Yeah, everyone just keep posting the answer, right? Thank you very much. And now I'm going to share an example with all of you, right? Everyone. Hey guys, just look here, right? I'm going to clear us what is some of the context here for all of you, and then I'm going to get back to the practicals here, right? Okay, listen to this example carefully. So suppose I have a okay, okay. I'm bad at drawings, but I'll try my best. All right, guys. For my upcoming practicals, I'm just creating a plot here, and it is going to take 5 minutes. 5 minutes only. And this looks like a tree. Okay, some roots and all. Right? Okay, okay. So it goes like, okay, everyone. Phone with cloud. Okay. Okay, fine. I'm really scared at imaginations of participants. I'm really scared of that. Okay. So it's a tree, guys, right? Let me mark this down. Tree, right? It's a tree. This structure belongs to one of the, you can say longest trees in on the planet. They're generally found in probably South Africa, I believe. But these are the longest trees. Like if we Google, you'll find this kind of architecture. Okay. Okay, so it's a tree, right? So you know that all the trees are having red, green, and blue color codes, right? So every pixel is composed of red, green, and blue something, right? Thank you, Sri Rama, for that thing. Okay, so every image or graphics that we see is composed of red, green, and blue pixels, isn't it? Sometimes red are on, sometimes green is on, sometimes blue is on, and sometimes these things are on at different intensity, right? So just look at this, guys, what I'm doing here. So okay, for my upcoming practicals, this example is going to create sense for the demonstrations, right? Just listen to me carefully. Okay. Hey shift, I hate you. Okay, just give me a moment, guys, right? I don't want any insensible information to be forwarded to my participants. So just to make sense to upcoming demonstrations, I'm just doing this. Hey, the value is between 256. Okay. Hey, let's do it quickly. Okay. Apologies for these strike throughs. Okay. Okay, great. You can say it's a matrix of, it's a 2D array kind of thing, right? It's a matrix. Okay, so this is the matrix, right? And this is the matrix of red. This is the matrix of green, and this is the matrix of blue. So guys, here I just want to create some sense here, right? So how you represent an image in in mathematical term, right? So if you want to represent an image in mathematical sense, what you're going to do is you're going to create a matrix here. So as you already know that there are three colors in any picture, such as tree. So for every color, there is some intensity or there is some value which is predefined for every pixel in the given image. So what I'm going to do is for every color, I'm going to create some metrics here. So here I've created three matrices, red, green, and blue, where each and every index consists of the given color value for the given picture. So let's say this is a tree, and this tree is composed of red, green, and blues. For the red, this is the matrix, and this for the green, this is the matrix, and for blue, this is the matrix. Now, what does it mean? If you combine red, green, and blue matrix all together, you're going to get a tree, right? So if you remove any of the metrics, it is going to manipulate the image. So let's take an example of editing image, right? Let's take an example of editing image, right? So what will you do when you edit an image, right? I'll just alter the values of RGB, right? So yeah, saturation, grayscale, right? And then beautify. Okay. So, these things, contrast and all, exactly. Thank you, Darshan, for that lovely responses. Thank you, Sunil, for that. So, for these alterations and, everything, you need to alter the values, right? So that's how we do it, right? So obviously, this is not a part of our course right now, that how to extract the red, greens, and blues. But, when you work with the matrices, right? When you work with the matrices, and when you are asked to alter the values in the matrices, and when you ask to reshape the matrices or manipulate or modify the matrices, what does it mean? Let's say an example of modifying an image. So if let's say if I change the value from 55 to, let's say, 78 here, and let's say from 43 to, let's say, 42 here, now the color of this tree from green becomes light green, let's say. Just an example, right? Or let's say if I do some changes, blah blah here and blah blah where, so it generally creates a bokeh effect, right? So it fades the unnecessary unwanted people in the background, right? So here it goes, like, right? So just wanted to create a context here, right? So how manipulating matrices is relatable in connection to the real life, you can say, examples or activities. So guys, can I ask my participants, are you okay? You got the idea exactly why matrices are helpful and how matrices are helpful? Everyone? Okay, great, great. Okay, great. Fine. Okay, I'm just closing this thing, and let's play with NumPy arrays, right? Okay, not play, it's fun with NumPy arrays. All right, fine. So let's have some fun with NumPy arrays here, right? So I'm going to do a lot of demonstrations here one by one, and slowly it is going to make some sense here, right? Okay. Okay, let's create an array of 10 zeros. Okay. Okay. So here I'm going to do what I'm going to do is I'm going to create an array of 10 zeros here. So it's like np dot zeros 10. Is that the right answer? Okay. Okay. So here you can see that I just created an array of 10 zeros here, right? So I'll just zeros and then print zeros. So it's like this, right? Okay, I just created an array of 10 zeros. So right now it it is going to feel it's insensible, right? What we are doing here. But let's take an example of a gaming, right? So let's say if you have 10 players with some initial state, right? So how you can represent 10 players or 1,000 players, let's say Clash of Titans, right? It's one of the game in Android where thousands of people uh, thousands of people come and fight. So how are you going to represent the states of thousands of people in one shot, right? So that's how we're going to do it, right? Okay. What if I want to create an array of a custom number, right? So if I want to create an array of a custom number, not from zero, right? I want to start with a zero. No, I don't want to start with zero. Okay, let's streamline it. I want to start with, let's say, 10 ones, right? So I want 10 ones here, right? So what I'm going to do is np dot zeros ones equals to float by default. So I have a question here, guys, I believe. Okay, zeros. Okay, zeros here and how many? 10. Print zeros. Oops. Okay. Array underscore 10 equals to zeros into 10. Array underscore 10. What I've done there? Once. Okay, I'm making mistake, guys. Just a second, guys. Right, just a second. Okay, let me calm down first of all. Okay, let's get started. Okay, 10 ones. Array of 10 ones. Okay. So np dot ones 10 ones. Okay. Print ones. Okay, first of all, let's keep it simple. What I have done here, I've used a function called, let's say, one, right? The function. What one generates an array of ones only, and how many elements you want? One, zero, that is 10. 10 elements you want. So it's here. It is zeros and ones is for the array of ones. But let's say I have a game there where the energy level of players starts with 5. So what I'm going to do is array underscore 5 equals to ones into 5. And let's print array underscore 5. So you can see here, guys. So I just gave you a small context here. Let's say if you have a game where the energy level of all the players, let's say there are 1,000 players, right? So there are 1,000 players, and when the 1,000 players are, are working or playing, so you want to start with the energy level of 5. So how will you start with the custom numbers, right? How will you start with the custom numbers? So this is logic, right? Yeah, Raj. Yes, Swati, I can see the chat. Okay. Okay, everyone, let me confirm once again. Can you hear me now? Am I audible properly? Okay, great, great, great. I'll repeat it once again, guys, okay? Okay, okay. In Python, okay, let me repeat it once again. Okay. Generating arrays. Here we're talking about generating arrays, okay? In Python, we have a function called zeros. We have a function called ones, right? These two functions are basically used to generate arrays of of n numbers. Okay, so it is going to generate 0 and it is going to generate 1. Now, why will you require some pre-generated numbers? Right? That is the question. Why will you require some pre-generated numbers? So, in order to answer this question, I just give you an example that let's say if you have a game, right? And in a game, let's say there are 1,000 players, and you want to start the initial state of every player with zeros, right? So all of a sudden, instantly, if you want to have an array with the values of 0 for 1,000 players and 1,000 elements, how are you going to do that? And that is np.zeros. And then similarly, we have np.ones. It is going to generate n number of values, right? And all the values will be similar, that is 1. Now, in this example, what if I want to start with a custom number, right? What if I want to generate an array of custom number? So let's take an example. I have a game where the energy level of, energy level of a player starts with 5. So you can simply multiply the number with 5. And yeah, Nishan and Shiraz, we do have np.full also. Okay, that's beautiful. Okay. Now let me give you some more demonstrations here, right? Okay. Now we have already done this arrange method, right? Okay. Let me deliver some functions and then we'll discuss, right? Because I need to fill you with the content of NumPy instead of apart from differences in the performance and time. Okay. Just let me fill you with the content of NumPy. So we have Rohan. That is for decimals, right? That is for decimals. Okay. So arange is a function which is equivalent to range function in Python, right? Which is used to generate numbers, right? I'll just show you an example here. np.arange 10 print arange. So you can see here, guys, it is used to generate a number, right? And then what if I pass two values here? Let's say 20. Right? So it's becomes start and end, right? I hope this is easily understood, right? Start and end, isn't it? It's like n minus 1 specifically. Okay. Now, what if I do this? What if I pass the third argument here? So, guys, can you guess exactly what is that? Yeah, it skips to it's a step or it's an increment. That's absolutely true. Okay. Now, everyone, listen to me carefully, okay? Now, in my upcoming demonstration, every last demo will work as a prerequisite. Okay, let's go with this. Here, creating a 3x3 matrix, right? So, okay, I gave you the example of a tree in which we constructed some 2D, 3D, 2D matrices. So, I'm going to show you exactly how to construct the matrices in NumPy as well. Okay, so here it goes like. Now, first of all, L equals to np.arange. I'm going to start with 10, right? Okay, print L. So here it goes like, right? 0 to 9. How many values I have? 10. No, I don't want 10. I want 9. Okay, so for 3 into 3, it should be 9, isn't it, everyone? So that's how I have calculated. Now what I'm going to do is L underscore 2D equals to np dot reshape. And then what I'm going to do is 3, 3. Okay. Yeah, thank you, Anku, for that. Yeah, Vasu, I'm going to come back to your question. Just give me some time, right? Okay, just trying to deliver as much as I can. I'll get back to the question as well, right? That's one of my part responsibilities also. Okay, now here we have a reshape method, right? Here we have reshape method. What reshape method does, it basically reshapes the, what do you say? It reshapes the structure of your array, right? So print slash n or dimension, that's true. Array underscore 2D. Okay. Once again, what I've done, array underscore 2D. Have I done any mistake here? Everything looks good, I believe. Yeah, that's true. Okay, that's true. Thank you, everyone. Okay, so here, okay, I need to call, the reshape method with the add object. Okay, fine. So here you can see the representation. Okay, everyone, change to 2D here. Okay, so you can see here it's the one-dimensional and it's the two-dimensional here, right? So that's how it goes like. Okay, that's great. Okay, let's proceed further and let's see exactly what else we have in our uh, what do you call that? NumPy array. Okay, linspace function, right? Linspace point. This, this function is basically helpful in some ways, but just as part of curriculum, I'm supposed to tell you. So this is also very frequently used. So let's look at demonstration here. What it does. Array equals to, np dot linspace. So what I'm going to do is 0, 1, 20. Okay. So what linspace does, right? So what linspace does is that it is going to generate numbers. Okay, it's going to generate numbers between 0 and 1, right? Yeah, it's going to generate numbers between 0 and 1 with a, you can say linear distance or linear distance of, let's say, 20 points. You can say like that. So let me show you the difference here. Print add. So in this array, what you can see is that in this array we have generated an array using the linspace method, but the point to be observed is that uh, in this array all the values are, first of all 20 in numbers. Okay, all the values are in 20 in numbers, and all the values are actually, equally spaced, right? So for finding, yeah, 20 distributions, you can say that, Ankita. So all the values are equally spaced. For finding the space between the values, you need to, do the subtraction and all. So I just let you that part as a homework. Okay, so that's how it goes like. Okay. Okay. Now let's proceed further. And here in this demonstration, I'm going to show you something about slicing part also, which is very important part. Okay. So array slicing. Okay. So let's create an array, guys. Okay. Fine. So I have a matrix here with the a range, and then I'm going to create a matrix of, let's say, 26. Okay. Create a matrix of 5 into 5. I think that should be good, isn't it? So a 5 into 5 matrix will help us, doing more demonstrations. Yeah. Okay. So, okay, it's a matrix here. So is it a matrix? Let's find out. No, it's not a matrix. So guys, it's a one-dimensional array. So can I ask you exactly what should I write here to convert it into 5 into 5 array? Okay, I need to reshape it. That's exactly true. So what I'm going to do is I'm going to reshape here, and I'm going to convert it into 5 into 5. Okay, so mat underscore 5t. Okay, so that's how we're doing. Let's print mat underscore 5t. Right. Okay, so if everyone is doing parallelly, they can simply follow the code right now. Okay, and let's execute here. Fine. Now, before I proceed further, I want to, ask all my participants, right? That is the important point. So whenever you work with the 2D array, right? Whenever you work with the 2D array, you are supposed to, work with x and y coordinates, right? So it's like rows and columns for x and y coordinates, right? You need to understand that how we access, the 2D structure, right? So you remember that expression, right? It's like 2 comma 1, right? This expression. So this is something which is important here, right? So if you want to access 1 here, right? So what does it mean? It's like from the 0 row, right? Okay, from the 0 row and the 0 column. Okay, bad. I'll write it here. So 0 row and 0 column, right? So this is 1, right? and then 0 row, 1 row, 2 row, 3 and 4, and then columns 0, 1, 2, 3, 4, right? So this structure is a prerequisite for working with, you know, 2D arrays, right? So let's find out exactly what we have here with this mat underscore 5D. Print mat underscore 5D 3, 4. So guys, any ideas what is it's going to do? So how we are getting the 20 value here? 20, come on. Yeah, Satya, that's true. Yeah, because for the because some participants are new here, so that's why I'm just playing the prediction game, kind of, you can see, right? Okay, it's the third row and the fourth column. Okay, so it's like 0 row, 1 row, 2 row, and 3 row. That means in this row. Okay, in this row we're targeting this row, and then the fourth column, 0 column, 1 column, 2 column, 3 column, and the fourth column, this one. So in this row, if you point out to the fourth column, it is going to be 20 here. Thank you everyone for the responses. So that's how we slice. That's the starting of slicing, right? Okay. Now let's do some more, slicing here, right? And this time it is going to be a little complicated, everyone, right? So let's see what we have here. And for this, your string slicing or list slicing will work as a prerequisite. Okay, so let's get started. Print matrix underscore 5D. Let me find the selection. So what we can extract this time? Colon 3, 1 colon 2. Okay. This sounds interesting. This looks interesting, actually. Okay, let's see the output, guys. So, see, exactly. Let's try to understand exactly how it is working, right? Let's see how you predict, right? It's an activity to enable self learning. Okay. Okay, great. So, can you okay, let's give it a try, right? Okay, it's going to be hard, but can you write the syntax here, like start and something like this? Okay, let's exactly see how precisely you understood the syntax. I think that's not the right answer, Srikant. No, it's not taking the third row. Can you see, Srikant? It's not taking the third row. Okay. Okay, okay. So I'll say it like this in case if it is not understood, right? It will start till row, okay, -1. It will start till row. It will start from 0, 0, 2. Okay, okay. So what you have given, right? So this expression, right? Comma. Okay, look at this expression. It'll start from 0. It'll start from 0 to row -1. So row is 3. So row -1 is 3 -1, 2. So 0, 1, and 2. And then comma, column, right? Column, and then n -1, right? So what numbers it will count? Column, that is starting from first column, and then you have specified end, and that is 2 -1, 1. That is only one first column only, right? So it is going to get me the values of 0, 1, and 2 rows. Okay, get the values of 0, 1, and 2 row, and from one column. That's what this question is all about. I will give you, 5 to 30 seconds more to go through the syntax once again. Yeah, sure, Satya. I'll just ping you here. Guys, NumPy doesn't require you to be very you can say champ in getting your things done. It just requires fundamentals, right? Once you're clear with the fundamentals, you can easily handle beginner to moderate level projects in data science or ML. So it's completely fine. Okay, the main point is that once you're into your real projects or your assigned projects, right? So at that time you should be able to understand the expression, and you should be able to edit and learn from the existing codes, right? So this is what right now I'm aiming for in just 2 hours of this NumPy. That's what I actually do in 2 hours. Yes, Subhadeep, I'll just do this for you once again. So first of all, you need to understand this part, right? So when I say this part, okay, first of all, freeze this in your mind, right? First of all, freeze this in your mind that before comma, it is a row, you can say row indexes, and after the comma, it is the column indexes, right? So before you learn anything in that expression, you need to finalize this thing. That's it, right? Okay. So this means that if you go by this expression, this means that this expression is a row, right? So here I'm talking about row here. So what colon 3 means, right? In every slicing expression, colon 3 means 0 to 2, right? Whether it is a string or whether it is a list or even numpy arrays, the meaning is same. So what does it mean? That all the rows from 0 to 2. So it's like 0, 1, and 2. So it's not going to take care of 3 and 4, right? So what this means this. Okay. So I think this should be clear now, as of now. 0 to 2. Okay, thank you, Manish, for your response. And then we have the columns there. So it is going to start from one column and this 2 n minus 1. Right? Okay, so 1 colon n minus 1. So it's like 1 colon 2 minus 1. So actually the whole idea is to store column only. So it's like 1 colon 1, which comes to 1 colon 1, that is 0, 1, 2 rows and 1. In the first column, this one, pick all the values from 0, 1, and 2 row, right? So from the 0, 1, and 2 row, in the one column, we have 2, 7, and 12. And that's 2, 7, and 12. It's confusing, Swati, but if you spend some more time with this, it is going to work. Thank you, Vinita, for this lovely expression. I mean, it can be in the less or higher. Okay, mat dot sum. It gives me the sum dot standard deviation. It gives me the standard deviation. I don't know for what purpose we use standard deviation. I used in machine learning, but it's completely okay with this. Mat dot sum axis 0. What does it mean? Row wise sum. Okay. Oh no, sorry. Axis 0 is column. Oh, that's same. Oh yeah, obviously that's same. That's going to be same. Okay. So here it goes, like. Fine. So that was just some mathematical function, right? Just wanted to tell you as part of the curriculum. Okay. Oh, we went too far in this, right? Fine. So guys, now this is time to conclude, right? Don't want to confuse you with any extra overburden, right? So this was all from my side in just 2 hours with NumPy. I hope when you will, start with NumPy again in future, you have the solid foundation of exactly what NumPy is all about, and why we need NumPy in our projects, and why NumPy is the favorite choice for holding the data in all the high-end libraries such as Keras and such as TensorFlow and all, right? So that's how it goes, right? So any questions from your side, guys? I'm done with the session. Not wanted to confuse you, right? Okay. Hey, Viva. Thank you for that. So Vasu, for that we have expressions, right? So I'm going to okay. Okay, you just need to Google a link for those expressions, right? And there was a question from one of the participant about the dots and ones, right? In ones it was returning dots, and in zeros, in np.0 it was returning dot, and np.ones it is returning one. I just want you to check the documentation of those functions, right? Simply, do this, right, and just go through the uh, documentation of that, right? Just want you to just cover this up. One question: how can slicing generate higher dimensions? Manveen, slicing cannot generate higher dimensions. Actually, it will generate the same. It will generate the same similar dimension or the lesser, but not the higher. For higher, you need to simply reshape it. Okay, Swati, how I get the documentation here? It's very easy. So after you type the standard or any function name, simply press Shift and Tab. I press Shift also, Raghu. Okay, fine. That's completely fine with me. Okay, so guys, okay. Sajal, is that a question? Sajal, what you are retrieving is the instance which is representing the Python list. It's like, Sajal, you are extracting the instance size of Python list, not the element size or complete size. Nishan, mat.sum is the addition of all the values within the given matrix. Yeah, that is a 2D matrix, Partha. Partha, there are three variables x and y and z. Yeah, so well, that's what I'm talking about. Object size, which is representing the list, right? Not the whole list. Hey, Partha, I'm not able to find x, y, and z there. I can only say x and y. It's 3 by 3, Partha. 3 by 3. Yeah, Nishan, we can do that. Standard deviation, right? That is a standard deviation. What I understand from standard deviation is that, suppose you have a matrix of, let's say, higher value numbers. Let's say where every number is greater than 1 million, right? So suppose if you have a matrix of, let's say, 1000 by 1000 size, and where every number is greater than 1 million, or it's a float or int64 size, you can say what? It's a int64 size element in each and every index, right? So in that case, it becomes really complicated to compute in terms of time and space both. So what we do exactly at that time, we draw the standard deviation of each and every number, right, in that matrix. Now, what does a standard deviation does? A standard deviation basically, draws the minimum number, which is equivalent to the higher representation or actual representation, which thereby reduces the size, which in turn saves the space, and computing the number which are smaller in size is compared to faster than computing the numbers or multiplying the numbers, let's say, or doing the math with the number with the higher size value, right? Okay, Karuna, thank you very much for that. I hope you got the idea exactly about the standard deviation. I forgot the person who asked me this. Darshan. Okay, thank you, Darshan, for that lovely smile. All right. So, are there any other questions from the participants, guys, or we can simply conclude the session? In my next session, I'm going to discuss the pandas library, which is the lovely library we have in Python, right? So nothing can be complete without pandas. Pandas is always there in any of the module you go with the go with any data science program. So pandas is always there. So Samir, okay, time complexity code. Okay, this one. So Samir, here's this for you. Shashi, there is a transpose function for that matrix. For the matrix, transpose is always there. Okay, done that. Okay, all right. So I think uh, all the questions are answered. Spaces are. Okay, Rahul, that will be by the grant, right? So I don't have access to the URL. Okay, everyone. So fine. So I think I'm done with the question. Everybody's done with the questions. Okay, so time for the goodbye message, right? So I wish all of you happy learning, right? And just keep up with the practice, and you know, that's it, right? Enjoy. Good night, guys, and thank you, Inshia, for your lovely support.
Great. Thank you so much, Mr. Rajan, and thank you everyone for coming to join tonight. We will share the recording with you tomorrow then. Thanks all. Good night.